And there is a relationship between the permutation and combination, that is NPR can be written as NCR into R factorial. Out of 10 ball, if I am choosing 7 red ball, it is same as out of 10 balls, I am rejecting 3 blue balls. So if we evaluate this using the formula, it will be one and the same. In case of permutation, if you have 10P2, you will write it as 10 into 9, only 2 factors. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. Today in this session, we are going to learn about the combination. So let me tell you what is the difference between the permutations and combination. So when I talk about the permutation, for example, arrangement of books in a library or your mobile password. So it will be in an proper order. So that means order is necessary in an arrangement. But when I tell you for the combination, you can take an example of choosing a menu in a restaurant, choosing 3 boys inside a class. So this is an example for a combination. So here the order doesn't matter. Let me take one more example here. In a class, arrange the boys according to their height. So we have to arrange in one particular way. But the same thing if I say choose any 3 boys out of 10 boys inside the classroom. So the choosing can happen in any way. So here the order doesn't matter. So whereas in permutation, order matters. So when we talk about the combinations here, so combination has a formula for finding the number of combination with n different object. Take an R at a time. So that means out of 10 student, choose any 3 student. So that can be represented as 10CR. So now the general form is NCR. Now here the order, as I said already, is not important when we are talking about the combination. And there is a relationship between the permutation and combination, that is NPR can be written as NCR into R factorial. So the only difference is here we need to multiply R factorial to get permutation. So when we are talking about the combination, so there is a repetition of some arrangement which is not required. So therefore, here in terms of combination, the formula NCR contains in the form such a way that it is given by n factorial divided by n minus R factorial and R factorial. So here R factorial represents the repetition of object which is not required in terms of combination. Therefore, we'll divide it by R factorial. So, whereas this is your NPR. So, therefore, we'll get an equation in the form of NPR by R factorial, which is equal to NCR. Hence, NPR is given by NCR into R factorial. So, therefore, total number of permutations of different things or objects taken R at a time can also be represented in terms of combination multiplied with R factorial. Now, some of the observation we need to study in terms of combination here is the formula of NCR is given by n factorial by R factorial into n minus R factorial. So, here R can take the value of 0 or n. So, that means we can choose nothing or we can choose all of them. So, that means R can take the value of 0 also, R can take the value of n also. So, therefore, NCN is equal to 1. But when I talk about permutation, so there are no 0 arrangement. There has to be 1 arrangement. So, therefore, their R cannot be equal to 0. So, completely there will be 1 arrangement already when we are talking about the permutation. But when it comes for choosing, so we can neglect the objects without choosing anything. So, therefore, here R can take the value of 0. Now, NCN is equal to 1 and NC0 is equal to 1. If you substitute here NCN, so then it will be like n factorial by n minus n factorial. So, it get cancels. N minus n is nothing but 0 factorial. 0 factorial can be considered as 1. So, the whole value will give you the value 1. And when I replace R by 0, it is n factorial by 0 factorial n minus 0 factorial. Here it get cancels and again 0 factorial can be written as 1. So, 1 by 1 is again 1. So, therefore, the value of NCN and NC0 is equal to 1. Now, next thing, NCN minus R can be written as NCR. So what does this mean? So selecting some of the object is nothing but rejecting the remaining object. For example, consider there are 10 balls. Now here 5 balls are red in color, 5 balls are blue in color. Now if I ask you to choose the balls which is of your favorite color, assume that you have chose red, which means you are rejecting blue, so which is the same thing. Now assume there are 7 red colors and 3 blue colors. Now I will tell you to choose a ball of your favorite color. So you need to choose all color ball which is of your favorite color. So again, if you choose 7 red balls, it is nothing but rejecting 3 blue balls. So therefore, here the number of combination of selecting some object is same as number of combination of rejecting some object. So therefore, the value will be same. Now if I write this in the form of a combination, out of 10 ball, if I am choosing 7 red ball, it is same as out of 10 balls, I am rejecting 3 blue balls. So if we evaluate this using the formula, it will be one and the same. Now suppose if there is NCA which is equal to NCB, then obviously A should be equal to B or N is equal to A plus B. So the number of objects, if A and B are different and their combination values are same, means either A is equal to B or N is equal to A plus B. So this is an example for that. So here they are not equal, but 7 plus 3 is equal to 10. Next, we need to show that NCR plus NCR minus 1 is equal to N plus 1 CR. Now let us consider the left hand side. So here we have N factorial divided by R factorial into N minus R factorial plus here N factorial divided by R minus 1 factorial into N minus R minus 1 become N minus R plus 1 factorial. Again here we can take N factorial. Here R factorial can be written as R into R minus 1 factorial. And here we will keep N minus R factorial as it is. Here N factorial divided by R minus 1 factorial. So this can be written as N minus R plus 1 into N minus R plus 1 minus 1 means it is N minus R factorial itself. So we can see here in both the terms N factorial, R minus 1 factorial and N minus R factorial are common. So let us take out. So N factorial divided by R minus 1 factorial into N minus R factorial. So what is remaining here? So we have 1 divided by R. And here we have 1 divided by N minus R plus 1. So let us simplify this. We will get N minus R plus 1 plus R divided by R into N minus R plus 1. Now here minus R plus R get cancels. So here we are left with N factorial divided by R minus 1 into N minus R factorial. Now we know here it is in the form of N factorial into N plus 1. So if you have 10 factorial into 11, this can be written as 11 factorial. So in the same way, N factorial into N plus 1 can be written as N plus 1 factorial. Now again here, R into R minus 1 factorial can be written as R factorial. And here again, N minus R plus 1 into N minus R can be written as N minus R minus 1 factorial. So now this can also be written as N plus 1 factorial divided by R factorial. Here I can take this as N plus 1 minus R factorial. Now if the formula is NCR, it is N factorial by R factorial into N minus R factorial. But here you can see in the place of N, we have N plus 1 both sides. So here also it is N plus 1, here also it is N plus 1. So the entire formula can be written in the form of N plus 1 CR. So that is the right hand side. Hence proved. Next question. If NC8 is equal to NC2, find NC2. Now here, when we have a property that NCA is equal to NCB, either A is equal to B or N is equal to A plus B. But here A is not equal to B, so therefore N is equal to 8 plus 2. So the value of N is 10. Now we need to find out NC2, so therefore we'll find 10C2. So in case of permutation, if you have 10P2, you will write it as 10 into 9, only 2 factors. So here also it's the same way, we'll write 10 into 9, but we'll divide with the R also, that is 2 into 1. So this is how we'll consider the formula in the simpler form. So the value is 45. Or you can use the same method using the formula 10 factorial by 2 factorial into 10 minus 2, 8 factorial. So when I say 10 factorial, until 8 factorial, all the values get cancelled. We'll get 10 into 9 by 2. So which is same as the value here, that is 45. Next question. Determine NC17 if NC9 is equal to NC8. So here A is not equal to B, but N can be equal to A plus B. So which is 9 plus 8, 17. So here we need to find out NC17. NC17 is nothing but 7C17. So from the property of combination, so if you have chosen all the objects at the same time, then the selection is only 1. So therefore NCN value is 1. That is 17. C17 is 1. Next question. How many chords can be drawn through 21 points on a circle? So chord is a line segment. So the minimum number of points to draw a line segment is 2. But there are 21 points. So obviously out of 21 points, we can select any 2 points on the circle. So therefore the number of chords required is 21 C2. So which can be written as 21 into 20 divided by 2 into 1. So 2 ones are 2 tens are. So therefore here 210 chords can be drawn using the points on the circle. Next question. In how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? So I need to select 3 boys out of 5 boys, 3 girls out of 4 girls. So therefore the number of ways here is out of 5 boys, I need to choose 3 boys. And out of 4 girls, I need to choose any 3. So here this can be written as 5 into 4 into 3 divided by 3 into 2 into 1. And this 4C3 can be directly written as 4 because we know that NC n minus 1 can be written as 1. So if you want to express this using the formula, we can also write this as 4 into 3 into 2 divided by 3 into 2 into 1. So which get cancels anyhow. So here 3 cancels, 2 ones are 2 twos are. So 5 twos are 10 into 4. So there are 40 ways of selecting the boys and girls. Next question. Find the number of ways of selecting 9 balls from 6 red balls, 5 white balls and 5 blue balls if each selection consists of 3 balls of each color. Now we need to select 9 balls, out of which 3 balls should be red, 3 balls should be white and 3 balls must be blue. So therefore the number of ways here is, we have 6 red balls, so we need to choose any 3, and out of 5 white balls choose any 3 white balls, and out of 5 blue balls choose any 3. So total we can choose 9 balls of different color. So now 6C3 can be written as 6 into 5 into 4 divided by 3 into 2 into 1. Similarly 5 into 4 into 3 divided by 3 into 2 into 1. Again here 5 into 4 into 3 divided by 3 into 2 into 1. So we can cancel 3 twos are 6, 6. So here it is 20. Now here 3 cancels, 2, 10. Similarly here also 10. So 20 into 10 into 10 is equal to 2000. So therefore there are 2000 ways of choosing 3 balls from each color so that you can choose 9 balls. So in this session, we have learnt about the formula of combination, how it works when it comes to the application in the statement problems. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.